People, I hope you're doing well, my delovelies, but please be careful with what I've got here. It may contain science. Explodey, fiery, death science. Hey, I told you we should be careful with it. Fortunately, the fiery death is long, long in the past. Sorry, dinosaurs. But the science about their end does still live on. And for that matter, so do birds. And we know how gifted and talented they are. Today, we think of the dinosaur extinction as a function of meteor impact, when approximately 66 million years ago, an asteroid absolutely bonked the Yucatan Peninsula, creating an impression 93 miles wide and 12 miles deep. But the Chicxulub crater wasn't even considered evidence of a Cretaceous-ending impact until the early 90s. Indeed, before paleontologists analyzed Chicxulub, researchers had hypothesized about impact as a potential cause of the Cretaceous-Paleogene, or Kpg, mass extinction event. People had found evidence of iridium dating to the Cretaceous to Paleogene boundary across the globe. Now, iridium is not common on Earth, but it is all over asteroids, and its presence strongly suggested some kind of impact phenomena going on at the same time as the Kpg extinction. And once the crater's geology was analyzed and dated, it explained a lot, and not just the iridium. So, over the last 3 decades, the Chicxulub asteroid impact has become the paleontological consensus behind the Kpg extinction. That isn't to say there aren't dissenters. It is, after all, very rare to find unanimity among scientists. And in fact, there have been other candidate explanations for the extinction event. The most popular alternate these days is volcanic activity in the Deccan Traps of West India, which was a leading theory before the impact hypothesis became the most popular kid in school. What's attractive about the volcanic hypothesis is its explanation of the Cretaceous's so-called 3-meter gap. In the last million years or so before the Kpg boundary, dinosaur fossils rapidly diminish. There are still a few found immediately prior to the estimated date of asteroid impact, so we don't think they went extinct before Chicxulub, but they certainly didn't seem to be thriving. So, as a single cause and effect explanation on its own, the impact hypothesis has a lot of supportive evidence, but it doesn't 100% explain the data, especially data like that. And like a giant space rock hitting the planet, volcanic activity is also known to cause mass extinction events. Volcanic eruptions in Siberia are blamed for the biggest mass extinction event in Earth's history, literally called the Great Dying, 250 million years ago. So, both phenomena can cause mass extinctions, both explain some piece of our archaeological record, and both are dated to roughly the same time, the Kpg boundary. Now again, this is not what most scientists believe drove the Kpg extinction. Most believe it was meteor impact, but there's a solid block supporting the minority viewpoint on this one. Scientists at Princeton and Dartmouth, among others, are strong proponents of volcanic activity as the driver of global dinosaur extinction, even if the impact did ultimately finish the job. Then you have the paleontological peacemakers who propose, hey, let's all get along, maybe a little bit of A, maybe a little bit of B, which pleases exactly no one. Because 1, fine. Then how much did each event contribute to the die-off? That is to say, which one was really the bigger deal? And 2, this is an academic turf war. We came here for blood, not for your milquetoast consensus. Shoo! But that's a flaw in the institution of academic science, right? That scientists are still people, still enamored of their own opinions and dismissive of others, like anybody else. The world is full of data, and there is an art to curating that data into a story, not in a deliberately fraudulent manner, but choosing what's most pertinent to include and what to exclude because you genuinely think that that data might be better explained by some other phenomenon. no scientist is truly, truly unbiased. And that's the issue that our authors, published in the journal Science, attempt to address today by modeling the extinction event in a manner with less than usual human input that might steer the conclusion. In order to disentangle the effects of volcanic activity from the Chicxulub impact, and to attempt to assess the relative contribution of each, this study used a parallel Markov chain Monte Carlo modeling approach, much like the technology that predicts your next word when you text on your phone. And this study worked backwards from the outcome to figure out not what happened geologically, but when ecologically disruptive carbon dioxide and sulfur dioxide emissions happened, and by extension, which of our world-ending events best explained the pattern. Interestingly, the model found that the Chicxulub impact did coincide with a sharp drop in organic carbon in the deep ocean. Organic carbon typically indicating, life stuff, which apparently lifened right around the time of the impact. But the impact wasn't temporally associated with any particularly dramatic spike in carbon dioxide and sulfur dioxide emissions, indicating that while the meteor did major damage and may well have emitted those gases, there wasn't a big ol' spike of them like you might expect if our meteor were the culprit. And so the destructive effects of the meteor may well have been through another mechanism. By contrast, the model in this paper estimated that the volcanic activity from the Deccan Traps was absolutely tremendous, enough to ensure that eventually the dinosaurs would have gone extinct, as if the victim of a murder mystery hadn't yet died of poison when he was shot in the ballroom with the revolver being a meteor in this metaphor. Over about 1 million years, the Deccan Traps are thought to have released about 10.4 trillion tons of carbon dioxide and 9.3 trillion tons of sulfur dioxide into the atmosphere. And of those million years, 300,000 were before the meteor strike, creating the time overlap that's made it so hard to figure out which horrifying apocalyptic event was responsible for what. So, how much do fellow paleontologists and earth scientists buy the conclusions from this paper? We'll see. One of the study's own authors says that most people in his field are more interested in the method used than in the particulars of the results. And to editorialize on this for a moment, that might have to do with the paper's conclusion, which countered the current field's consensus, and yet conveniently does accord with the author's prior allegiance to Team Volcano. Now, this is the first time that this type of parallel inversion statistical modeling has been done in earth sciences, which may explain some methodological skepticism the study's authors are getting. Not only are scientists a little wary of that which is new and untested, but scientists, again, are people. And many of us as people often look with a more critical eye at methods that lead to conclusions we don't agree with. If the model validated the impact hypothesis, you gotta wonder, would those same scientists be looking at it askance? And yet they are interested in the methodological approach, at least in principle. If these models can be validated and refined in that field, they'll be useful for other earth science studies where the ultimate outcome is known, but the factors that cause it are still muddy, like the extinction of the dinosaurs. That outcome is surely known, but also for phenomena like the climate and carbon cycle. And because it's often way easier to observe and describe an outcome than to untangle the knot of factors that could cause it, this kind of approach could have real utility in the field. But let's focus up. Where does this leave us with our dinosaurs? Do we buy the results from this paper and blame volcanoes for most of the dinosaurs' woes? Well, we can tell that the end of the Cretaceous was not exactly happy fun times. Even before the Chicxulub impact, dinosaurs were clearly experiencing climate disruption and dwindling numbers. That said, I don't personally rush to the headlines that assert now we've got it all figured out. Modeling can reframe and recontextualize our data in more useful ways. It can give us more certainty about the kinds of probabilities we're dealing with, but they can't magically turn circumstantial evidence into definitive conclusions. The past few years have seen alternate models that support the absolute opposite hypothesis, and while this study's model may have minimal human interference to put a finger on the scale of the results, that doesn't make it intrinsically more correct, just less influenced by humans. As old as the dinosaurs are, the field investigating their demise is still incredibly young. Again, the consensus around the impact hypothesis coalesced just 30 years ago, which is practically nothing in science time. The hypothesis supported by this model puts more respect on volcanic activity as a major factor in end Cretaceous environmental conditions, and it does address that 3-meter gap and other meaningful questions in the fossil record. But we have plenty of time to refine our approach to answering this thorny question. And in the meantime, let the academic blood sport continue.